So, welcome back. This is my second video for this same series of questions that I'm about to solve. In the last video, that isn't out yet because it's a long video and I need time to record my audio. So, in that video, I solved question 17 and question 18, and we learned a new formula for rationalizing fractions and also the fact that some fractions cannot be rationalized, right? So today I'm gonna solve the trigonometry related questions, question 20, question 21, question 22, question 23, question 24, and yeah, that's these six questions. Today we're gonna solve these six questions. So yeah, let's continue. So basically, essentially, um, the trigonometry questions often just require you to solve them, to factor them out, to solve them, to expand them. For example, there's a 2x here. This question might require you to expand it into sine 2x expansion, the composite angle formula, or the cosine 2x expansion, the composite angle formula, and double angle formulas for them. It might require, it might not. You need to know the common expansion formulas, or the common any general identity from trigonometry. Honestly, every general identity from trigonometry might come in handy. You never know. You need to be proficient in those. But normally in limits, the only thing that you find really handy is a formula sine x. Actually, I'm not gonna write x, I'm gonna write h upon h, where h approaches zero. uh, where h approaches zero is equal to 1, right? If you have read the book, if you're here because of the book, then you know the derivation for this formula. I don't need to tell you. And there's another derivation for this formula, which is cos h minus 1 upon h. That was the other way around. I remember that is equal to 0, I think. I think that is equal to 0. Yeah, that's pretty much it. Again, you can refer to the Thomas calculus book if you are not familiar with these formulas. They have very basic derivations. You just need to know them and then you're good to go. These two are the formulas that come in handy when solving trig questions. Alright. So the first question is question 19, tan 2x upon tan pi x, and the limit approaches x approaches 0, right? So we are basically accounting for the value of this fraction, the value for this fraction when x is approaching 0, from both sides, from the negative end of the graph and the positive end of the graph. That is the only case where the limit exists. Otherwise, the limit does not exist. Exist. Oh my god. Exist. Acha. So yeah, I'm gonna write it down here for you. Limit x approaches 0, where you have tan 2x upon tan pi x. Right? Um, so the first thing you need to do is expand, right? Tan x, everybody knows the formula, the basic tan formula. Tan, let's say y equals to sine y upon cos y, right? So we are just going to expand this really quickly. Limit x approaches 0. Uh, wait, yeah, sine 2x upon cos 2x all upon sine x upon cos yx, and you simplify it into a limit, which is sine 2x cos upon sine minus multiplied by cos x, right? So now what? Now what do you do? So basically, when you are dealing with this formula, when you're dealing with these two formulas, you have to introduce variables. You have to introduce variables. Why is that? Why do you need to introduce variables when you're working with these? If you are not given an h underneath, right? If you are going to just assign h and it's the position 0 and h underneath, okay, that's a stupid example actually, because then the answer would simply be 0. Say there's actually two h in here. Say there's actually like, or like hx in here, and you have h here, right? You only have h under here. H and x both are variables, so you just multiply the above and below with x, and like you get hx underneath, the hx underneath, and the hx here for form of 1, and the x will be approaching to 0. For example, yeah, x might be approaching some other value other than 0, right? So whatever the value x is approaching, because of this multiplication here, 1 multiplied by x, that would be your answer, simply put, right? We are considering here that h is approaching 0, like I mentioned here. H is the variable that's approaching 0, right? So whenever you're dealing with sin h upon h, whenever the h's don't match, the h above and the h below, like the value above, the value in the brackets of sign, and the value below do not match, you have to introduce a variable or a constant, but you have to introduce something, right? So here we have sine 2x and sine pi x. We need to match them. We need to somehow match them so that we get sine pi x in the numerator, so that we match the denominator sine pi x, and we need to have sine 2 and 2x in the denominator, because we need to match the numerator sine x, right? So basically, and whatever we multiply with the top, like if we multiply y on the top, we have to account for that by multiplying a y on the bottom, because the y cancels, then it's essentially a 1, right? So the value of the fraction does not change. That is the basic uh, requirement to multiply and like have introduce a variable. I'm sorry about that. All right. So what you're gonna do is rewrite expression 0 sine 2x cos pi x, sorry, cos pi x, all upon sine pi x cos 2x, right? And we are going to multiply it by 2x and pi x, because we need both of them, upon 2x and pi x again, right? Because basically 2x and 2x and pi x cancel each other out, right? So now this pi x, I would like actually circle with something else. This pi x and this sine pi x actually make a 1, and this sine 2x and this 2x make a 1, right? So if we rewrite it, we're going to rewrite it as limit x equals 0 cos of pi x upon cos of 2x, and just expanded a bit, we have multiplied by 2x and multiplied by pi x, because these four form multiplied by 1. Okay. If we put the limit there, if we expanded the limit there, I'm not adding those extra steps. The video is already 9 minutes long, so I actually like shouldn't. But so cos actually, like when cos h is approaching 0, when cos h, where h approaches 0, is equals to 1, right? Cos h cos 0 equals to 1, simply put, right? Yeah, this is something you should know already if you're solving limits. I don't know why there's this line there. I will erase that. Okay, the L also got erased. Yeah. So now we can just put in the limits, right? We can just put in the limits, because cos at 0 is 0, and like we will not be getting a 0 in the denominator. Also notice how the x is cancelled out. The x just simply cancels. So we put in the limit and we get limit x equals 0, question 19 is equals to 1, cos pi 0 is going to be 1, and cos 0 is 1, right? Pi 0 is going to be 0, and cos 0 is 1. This expression and this expression are going to equate to 0, cos x is 0, and cos 0 is 1. Multiplied by 2 on 1 multiplied by pi, which simply gives you 2 from pi, which is our answer for question 1. This is our answer for question. Yeah. Thank you.